Okay, I know we've already done a 3.1, but I wanted to give a few notes, a few reminders as we move on, just to make sure that we've got down and understanding pretty well what we're doing. Uh, First step to this is the fact that when I have whatever my index is, so a 4 there, means I would be doing the fourth root of all of those, meaning that really I need to make a group of 4 of something before I can take it outside of the radical. So for 81, for instance, I could split that up into 9 times 9, which splits up into 3, 3, 3, and 3. It's one of those 3 to the fourth power. Beneficial to know because it's popping up a lot in areas like this. Just makes it go that much faster for you as you're working it out. So that's one group. When I circle it, I'm going to put it on the outside of the house. And I have 5 x's. Okay, I need 4 to make a group. So that's one group of x's. I'll put it outside the house. Okay, keeping in mind that I've got one there. I have 3 y's. So those y's, I'm not able to make a group of 4, so they don't get to go outside the house. They're going to stay on the inside. So that's a cubed root of, I have 1x left, so I'll write that just as x, and 3 y's I'll write as y to the third power. Okay, we'll look at next one. What they're adding here is that you're multiplying together. So all that it means when you multiply is that you can combine these. If you want to multiply the numbers together, you can, but since they're already separate and you're about to separate them anyways, I would suggest just leave it as 2 times 4 and then put 2 x's and one more. It's 3 x's. And then 1, 2, 3, 4, 5, 6, 7 y's. So splitting up, that 4 splits up into 2 more 2's, which means I've got a group of 3 that'll get to go on the outside. Then I've got 3 x's, and I need a group of 3 to be able to hop outside. So once I circle it, it's going there on the outside. Then for y's, got a group of 3 there, a group of 3 there. Gives me 2 y's multiplied. They can go on the outside. And I've got one little y that's left, so it's going to go back inside and stay just like that. And the other thing that we did was add together. And so the rule for adding, have to have the same index. So index would be the 3 and same radicand, which would be the number inside the house. Okay, so if it's got the same thing inside, basically, if everything behind your coefficient looks the same, you can add it together. So for this one, I have 2 square roots of 5 plus 4 square roots of 5. Same thing as if I said I have $2 plus $4. I have $6. It doesn't change to anything other than dollars. So this doesn't change to anything other than the square root of 5. So just equal to 6 square root of 5. Okay. The next couple of ones are similar. On the ones where you're doing division, you are going to have to decide which one makes the most sense to you for how to split it up. I see 125 and 1000 as being easy to split up into groups of 3. You might choose to divide those by 5 and kind of simplify in that way. Well, I guess you could dividing by 5 3 times, and you'd end up with a smaller number that would still get a square there. But we're doing this. Easiest way I see, split up 125, knowing that it's 5 times 5 times 5, gives me one group of 5 that would be able to come outside of the house. And for 1,000, 10 times 10 times 10 gives me a 10 that would come outside the house. And I just simplify to 1/2. The other way, if I divided both those by 5, it'd be 25 over 500. Divide them by 5 again, be 5 over 100, I believe. Well, no, I see I've already gone wrong there. 10 divided by 5, that'd be 200. That's better. And then 200 divided by 5 would be 40. And then 40 divided by 5 would be 8. So it would equal 1 over 8. And I do the cubed root of that, which would get you to 1/2 as well. So either way works. Haven't done that way before, but it's still going to work out for you if you carry it all the way through. Same way, looking down at number 5, if I have 21a, the square root of 21a over square root of 3, taking that, and I could work it out both ways and say I could split up 21 into 7 and 3. Doesn't get me very far, but if I were to combine that 3 with the a and split it up into square root of 7 and the square root of 3a, then I'd be able to cancel out. In this instance, though, it makes a lot more sense to combine them inside, say 21a over 3a. Then the a's cancel out. 21 divided by 3 gives me 7. So would just very quickly simplify it just the square root of 7. Okay, I skipped over number 4 here, but when I'm multiplying here, instead of multiplying 75 and 12, what I would do is put them together underneath, then split them up. So 75 being 25 times 3, 12 would be 3 times 4. Already gives me a pair of 3s. Put a 3 out there. 4 splits up into 2 and 2, which gives me 2 out there. And 25 splits up into 5 and 5. So there's a pair of 5s. Then I'd multiply those together, get me 30. So for that one, everything does end up coming out of the house. Number 9, similar to number 2, but if you notice, I don't have the same number underneath there right now. So what I'm going to do is, let's see if we can simplify this a little bit. Maybe pull out a few pairs. So 45, I think of splitting up into 9 and 5. 9 goes into 3 and 3, which is a pair that'll multiply by that 4. So that gets me 12. 5 stays inside the house, so 12 square root of 5. Then I've got a -3 square root of 20, which splits up into 2 times 10, splits up into 2 and 5. So that gives me a 2 to multiply by that -3 to get a -6 square root of 5. So now, since they have the same thing at the end, I can subtract. We get 6 square root of 5. Okay? All of this adds on to those basic principles. So taking and combining, number 10, for instance, when I multiply them together, that would give me 8 times 8 and then x cubed, which gives you something that's going to pull apart and all come outside of the house to go with that x that's out there as well. Looking at the other page, again, working in the same way with the fractions. As I'm splitting that up, for this one, it'd be beneficial to multiply. So when I combine that 20 and 4 here, I'd get 4 times 20 over 5, and then x to the third with another x. Gives me 4 x's there. Put all that underneath the square root. So I leave this separate because I know 20 can divide by 5 and would simplify down to just 4. So I'd have 4 times 4, which is actually just a pair of 4s, right? So that means I'd have a 4 that comes out. Also have a couple pairs of x's to give me x squared. And so again, a lot of this is just deciding which way you want to do it, knowing that it'll still work out, whichever way you choose to work it out. Checking the addition, subtraction, and the index, the radicand, to make sure that you are building the right size groups as you go throughout working these out.